All right, y'all. Let's put it all together. Do example 8. We have a chart. We have our graph. Hey, first question. Is the graph even or odd? How do you guys know it's even? Go, what's up? I'm proud of you guys. What? Don't look at it. Don't look at my alerts. All right. Let's put it all together. First question, domain. Domain. Nate, now is your, or Mr. R, now's your time. What's the domain? Deal with.
Negative infinity to positive infinity.
It is, because what are we looking at?
Infinite graph.
You're looking at what part of it?
Yeah.
The x. Do you guys want me to use brackets or parentheses?
Well,
You can't touch infinity, right? I like that. You can't touch it. It's like MC Hammer. Now for my range, on this one, do I have an absolute max?
no.
Do I have an absolute min?
Yeah.
So now we know that terminology, right? For a range, I start at my absolute max or min. We're putting it all together. What's my absolute min? They told us it. Have you guys noticed that? Now, do we touch that negative 8.1? Yeah. Now, do I have any bounds at the top? Nope. All right, we're ready for this quiz. Let's take it right now. Ooh. Let's see if you guys remember this. How many degrees is this function? We know it's even. Now, if it was 2 degrees, that'd be x squared, and x squared looks like a... How do you know it's... Well, x cubed is odd, so it'd go like this. How do you guys know x to the 4th? Oh, I liked it. Say that again, Mr. Ohio State. There's 3 points of inflection. If there's 3 points of inflection, how many degrees is it? 4. I like that. I don't know if you want to... I don't know if I can call you that one right now. Because what's happening with Mel and stuff right now. All right.
Just made a phone call.
Quart. We're going to call this a quartic. Because it's a 4th degree. Quartic is a 4th degree. Yeah. Just like you said, we have cubic, right? That's our 3rd. Quartic. What is 5? I don't know. Don't post this. No one claim this. All right, let's do another one. We'll cut it in post. Yeah, this is probably my last day anyways. Shh, don't put that in film. All right, let's look at these. Oh, no. You guys want to see? Oh, wait, hold on. Bless you. You guys want to see something cool? Haha. Look at that, guys. And you guys said I couldn't do this job. All right. Zeros. How many zeros do I have on it? 3. Where do they occur at? I like it. See, you guys got this. I didn't need to do this. Hold on, though. What's negative 5's multiplicity? 1. I'm going to put their multiplicity in parentheses. That's not usually what you do. We know it's odd because it goes through, right? If it goes through, this is something algebra 2. We're going to talk about in more detail as we go. But if it passes through the graph, it's an odd power. Another 0 we have is at negative 2, right? Now that one, does it go through or bounce? Bounces, so that one's 2. Multiplicity of 2. Let me put it all together at the end. Well, let's see if we can figure, at 2, does it bounce or go through? When it hits the x-axis, does it go through it or does it bounce off it? It goes through, so it has to be odd like you guys. And it's a 1. I know, you guys resemble that remark. All right. Now, quick check. How many degrees is our function? 4. What should our multiplicities add up to? Do they? Yes. No, I'm not. This is a nice little review before we take that quiz. So would you guys agree from -4 to 2? Negative style?
Negative style.
-4 to 2. And what was the other one? What? No, they tell you the point right here. They helped us out. They gave us that vertex. Sometimes. So that means where am I decreasing?
Everywhere else.
Yes. Nice little review. Look at this. Just in time. What happens in 97 days? So that's what? Negative infinity to... Hold on, quick question. Why am I putting the -4 in brackets here like I did over there? With increasing and decreasing, it's always going to be brackets. Because at that point is when it is still going through. Technically, at that point, it's constant. But we'll just play it. And then my other one is what? From -2 to what? 0.9. All right. Do I have any relatives? Do I have a relative max? Is that my only relative max? So it occurs at -2. It is 0. So my relative max is the point -2, 0. Do I have any relative mins? Yeah, we have 2 relatives, and one of the relatives is also an absolute. I'm just going to list both relatives. If you guys just want to get in the habit of always listing them, you won't be wrong. Does that make sense? Anytime you see one of these little lumps. So that one is at what? -4. Doop. Or the chance I remember to edit that part on my video, 0. All right, what's the other point then? Yep. Do I have an absolute max? No dice. No, that you don't have an absolute max then. It's none. Nope, you can't put infinity as an absolute max or min. If the answer is infinity or name infinity, that means you don't have one. Yep, you can put NA, none. It does not exist. You go full, nope, we'll save that one. Oh, I did leave it here. Do I have an absolute minimum wage? Yes. -8.1. Now you could list the point, but the absolute minimum of that graph is -8.1. You don't get below it, right? You could have also said at 0.9 -8.1, right? There's many ways to say these things. Like technically I said the relative maximum occurs at this whole point. Relative min. Now how do I find my POI, my POI? I have to in between two. Do I know my relative max and mins? So that means what do I do when I have those points? Rule 3. Yep, we're going to find the midpoint between them. So the first point of inflection, I would do -4 plus -2 over 2. Dude, look how, that's the crispest line I've ever drawn. Crisp, like an apple. And then the other one would be -4 and 0, right? Oh, now you're lagging. I see it. Oh, back to the good old days. And that point is what? -3, -2. So that's one of my points of inflection. And you guys can look at your graph. Does that look like it works? That looks pretty good. I don't think that's bad. Some would say it's great. Why'd they do that? All right, where's my other point of inflection then going to be? I would do -2 plus which point? 0.9 over 2. And then was it 8.1 plus, -8.1 plus 0 over 2, right? All right. So what's that equal to? That's 1.4, negative 1.45? No, wait, nope. I can math. Negative 0.4, right? 0.45.
No.
Math is tough.
Negative 0.55. Yeah.
That's what I said. Let's rewind the tape. Negative 0.55, and then this one would be 4 point.
Yeah. 4.5.
Does that look about right?
Yeah.
All right. And the last one, I'm just going to add them down here. M and N. Where am I concave up? Negative infinity 2. Now, I'm doing an interval. Where do I get my x interval? I use my points of inflection, right? Because that's where it changes. So I go from negative infinity to -3. And we can look at our graph. No. Only increasing, decreasing. At a point of inflection, some weird stuff's actually happening. Now, is there another one that's occurring too? What's the other one? Negative 0.55 to infinity. Now, when you look at your graph, do those both look like U's, those intervals? Okay. So then where am I concave down? -3 to negative 0.55, right?
Yeah.
All right. This is a great review, right? That covers a little bit of everything. Yes. Only use brackets for increasing, decreasing. Derivative doesn't exist at that point. That's why.